about running. So maybe a few weeks ago, I woke up, put my shoes on, and I got ready for my daily morning jog. And then I felt a really strange feeling. When I started running, I actually started feeling a little hazy. And I thought it was what's described as runner's high, but turns out I was suffering from smoke inhalation. You see, I live in California, and even though most smoke in our state is caused by Prop 420, this time it was from wildfires. California was on fire. My California was on fire. And that's not good. I was curious about how I could be of value. So I thought maybe I could become a volunteer firefighter, but unlike me, firefighters need to be able to lift more than 10 pounds. Then I thought, could I help the community in a different way? Could I predict where fires are spreading so the community can be warned beforehand? So I decided to call my friend Fernando. Fernando's all the way on the East Coast. Where he's from, hurricanes appear on a yearly basis. And he wondered, could he predict the hurricane speed and warn residents beforehand more effectively than current methods? So I insisted we solve wildfires. He demanded hurricanes. I asserted, he stood firm. And we're having a classic East Coast, West Coast rivalry. Well, after a night of battling, Fernando actually ended up winning because he is 3 hours ahead in time zone. So he got a head start in coding. And hurricanes it was.
So our question was, how do we even get started? We need some AI knowledge and some remote sensing knowledge. Turns out AI was the easy part, but average Joes like us couldn't figure out how to download the data. The quickest way to kill motivation is to make things unnecessarily hard. By the time we figured out how to get data and train models on the feeble GPUs offered by Colab, our passion to solve the Earth's problems was exhausted. We realized that there were too many barriers for a beginner to get started, and so we decided that we wanted to simplify the entire process.
If you want to make something popular, well, first, you have to make it accessible and easy. Easy to download the data, easy to train the model. The problem with easy is that easy often means beginner, and beginner often means slow. On the other hand, in industry, at places like Google and Amazon, experts need things to be fast. And to be fast, they develop complex pipelines that are far too complicated for your average Joe to use. But we want to combine the best of both worlds. Why can't we make something that is both fast and easy?
And so our project over the last 8 weeks has involved creating fast and easy access to remote sensing data. And luckily for us, through the grapevine, we heard that your team at NASA Impact is working on something related to hurricanes. We magically found out about an incredible data set containing several thousand images of hurricanes.
To make a long story short, the steps we had to go from getting the data set to training a model were not as simple as we hoped. We first had to get the zip file URL, download 4 gigabytes, during which my internet connection disconnected midway, so I had to download it all over again. Then I had to unzip it, read through the file names to understand the naming conventions. Then we had to write a parser to get the speed from the image name. Then we had to write a script to clean some noisy images in the dataset. And we have TensorFlow or Keras accepts data in a certain format, and those helper functions were not exactly useful with this data. So we had to write our own image and label loader. And then finally, we got to train. And when we finally got the chance to train the data, it was slow, pretty damn slow.
We figured there must be an easier way to get data and feed a model than to have to go through all of these tedious steps. So the question is, can we make this easy?
Enter TensorFlow datasets. These are sets of prepackaged datasets that are ready to be used in efficient TensorFlow deep learning pipelines with few lines. So we figured, why not turn the hurricanes dataset into a TensorFlow dataset? Then anyone in the world would have the data ready to use. And that's exactly what we did.
With hurricanes as a TensorFlow dataset, we can have everything ready to go in a training pipeline with one call to tfds.load. And even better, TensorFlow datasets are the optimal format from training. But don't take it from us. Take it from our resident expert, Mike. Mike, you played with the dataset before meeting us. How long did it take you to get the training pipeline running for the very first time?
Well, I ran into the same problems that you just mentioned, and all said and done, it took me about 3 days. I had to modify the data and format that runs with Keras.
And then with the TensorFlow dataset that we shared with you,
Oh, that was a breeze. It was like I could run it as is. Took like a minute.
your smile says a lot. All right, Mike, how long did it take you to train originally?
The original setup was about 7 minutes per epoch, or in my time, 425 seconds.
And now with the new pipeline?
Like about 6 seconds per epoch.
So only 70 times faster, not bad. Now, making tiny changes to the images called augmentations is essential for making a robust classifier. And that makes things much slower. It took 575 seconds with normal Keras augmentation. With contributions from Mike, we incorporated GPU accelerated augmentations, and it takes only 7 seconds. That's 80 times faster. And by the way, Mike, when did you start programming?
I wrote my first Hello World in Python about 90 days ago.
I would say that this is the ultimate mic drop moment. Let's first look at how this speedup was achieved. First, we parsed the dataset and stored it in an efficient TF records format. Second, we realized that too many small files in kilobytes can have a lot of overhead and seek time. Similarly, large files in gigabytes can reduce opportunities to parallelize data processing. So we combined several files in the sweet spot, about 180 megabyte TF record files. Now that the data is ready, we encapsulated it all as a TensorFlow dataset. Normally, while the CPU does data processing to get it ready for the GPU waits idle. Then when the GPU trains, the CPU sits idle. This interdependence leads to a big source of resource wastage. Since our dataset is in the tf.data land, we get the opportunity to do prefetching, which essentially passes data between CPU and GPU asynchronously and reduces waiting by a large amount. Lastly, normal augmentations in Keras are done on the CPU. Your CPU only has 8 to 10 cores, whereas your GPU might have 5,000. So we utilize GPU accelerated versions of those augmentations, including rotation, brightness, cropping, zooming, and shearing. So that also contributes to the huge speedup. And that's why it's more efficient. And to be clear, all these tools were already available. We just joined them together. Mike, I have one last question for you. How would you describe this pipeline?
Plainly put, fast and easy.
So the point is, with prepackaged and publicly available TensorFlow datasets, we have the opportunity to simply access efficient training pipelines and get more people excited about investigating what is possible. For the hardcore scientists, we want to save your time, get you more productive. And thanks to amazing help from Brian and Iksha from the NASA Impact team, we are currently not far away from packaging multiple NASA Impact datasets, such as hurricanes, dust storms, smokes, and clouds, all as TensorFlow datasets. In summary, if our evil master plan works, everyone and their mother will be training hurricane classifiers. So Fernando, are we done here?
Well, we took a dataset of hurricanes and created a TensorFlow dataset, which enables practically anyone to be able to train models in very few lines of code very efficiently. But what about something broader, something other than hurricanes? How about any region in the entire world?
So that's exactly what our next goal was. Find a fast and easy way to get training data from any region in the world. Since every user has a different need of data, we have two options to make everyone happy. Option 1, get MODIS data of the entire Earth, similar to what you see on Worldview, for 12 days, one for each month, and package this as a TensorFlow dataset. And you run the 2 lines of code as we show here, and you're all done and ready to train. All we need are the necessary permissions to upload this as a dataset to TensorFlow. Now, option 2. Some users might want more customized control, a particular region, a particular set of dates. So we have created a system which accepts 3 parameters passed by the users. First would be coordinates for a rectangular region of the world. Second would be the dates. And third would be a desired tile size. It then facilitates and enables users to download the data for their desired regions, tile it into a specified size, and write all the data to a TF record format, which also stores the coordinates of the top left and bottom right corner of each tile. Sounds pretty handy, right?
Certainly does. And to satisfy Shivam's demands for working on wildfires, we downloaded a data set of the fires going on in California, and with our pipeline, we created this video. Well, I think that's pretty neat. And did I mention that it does all of this in only 2 lines of code? That's right. With only 2 function calls, we simplified the process, which took us weeks to understand in order to save any other beginner or expert from the painstaking process of acquiring remote sensing training data. In summary, whether it's a hurricane or the entire Earth, I would say that 2 lines of code to get data in the most efficient format for training is, what's the word I'm looking for? Both fast and easy. Thank you very much.